one of the earlier model which was given by Niels Bohr for explaining the structure of the atom. ये जो एटम है इसके स्ट्रक्चर को समझाने के लिए नील बोर ने एक मॉडल दिया था. Okay, fine. So what all did he say? Fine. He gave us three expressions. First was for radius, which is given by the formula 0.529 n square by z angstrom, where 1 angstrom is 10 raised to power minus 10 meters. The second formula that he gave was of velocity, which is 2.18 into 10 raised to power 6 z by n meter per second. And the third formula that he gave was for energy, which is minus 13.6 z square by n square electron volt per atom. Okay. Now, r is radius, v is velocity, E is energy. Okay. N is number of orbit. And Z is atomic number. Z is atomic number. ठीक है? Fine. Now see, Bohr model is applicable for Bohr's model is applicable for hydrogen. Atomic number of hydrogen is 1, right? Because it has got only one proton. Then it is also applicable for He plus, 2 proton. 3, 4 protons. Okay, applicable for 1 proton, 2 proton, 3 protons and 4 protons. That is, it is applicable for hydrogen, He plus, Li2 plus and Be3 plus. Okay. Now, to understand this model better, first we will do, what we will do, we will do some calculations. Calculate the A part, radius of first orbit of hydrogen, He plus, Li2 plus and Be3 plus. So beta, you have to use this formula. Okay, you have to use this formula, and when I am saying first orbit, it basically means n is equal to 1. The value of Z I have already given. I want the answer in angstroms only. Very good. So what do we get over here? R is equal to 0.529. This is n square by Z. So into 1 square by 1 angstrom. So this is 0.529 angstrom. For He plus, this will be 0.529 into 1 square by 2. For Li2 plus, it will be 0.529 into 1 square by 3. Okay. This is the answer that we are getting. Huh? So, now the second question. Any doubts to anybody in this question? Everybody has got the answer? Very good. Okay. Now B, velocity of electron in first orbit of hydrogen, He plus, Li2 plus Be3 plus. Calculate करेंगे बेटा. See friends, this is the answer that you must be getting. Huh? Fine. So you calculated the radius, you have calculated the velocity. Now the third part is calculate the energy. Now see, I have not done the calculations over here. I have just left it like this. But in the case of energy, all of you are supposed to do the calculations up to the, what I can say, the first place, second place of decimal at least. Do the full calculation. That is very important. Okay. So calculate the energy of electron in first orbit of hydrogen, helium, lithium, beryllium. Do the calculations. Yes, what is the value for hydrogen? What is the value for helium, bachcha, tell me? Right? What is the value of lithium? Tell me. Okay. Now let us understand what is the inference we can draw from these values. See my dear friends, in the examination, whether it is IIT-JEE or NEET, they are not interested to see whether you are able to calculate it or not, because you can do calculations by your scientific calculators nowadays. What they are interested to know is how you will use this data. What inferences can you draw from this particular data? So now what I am doing is, I am giving you those inferences which can be asked to you in the form of a true or false, which can be asked to you as which of the following statement is correct, which can be asked in the form of assertion and reasoning, which can be asked in the form of matrix match. Right? So what inference are we drawing from this particular part? See what is happening, the atomic number is increasing. So what happens to the radius when the atomic number increases? What happens to the velocity when the atomic number increases? And what happens to the energy when the atomic number is increased? Tell me, what is the inference you guys can draw from it? Tell me. So, what is the inference? As the atomic number, this is a very good question which one center has asked, that has been asked from Sirsa. Yeah, sir, as atomic number increases, velocity also increases, but energy decreases. Why so? Dear friends, when we are talking about energy which is decreasing, this is a very good explanation. In fact, I should appreciate the question asked by the student. Let me tell you, but before that, let me just write down these inferences, then I'll once again take the question from Sirsa and will give you the answer for it. It's a very good question. Okay. As the atomic number increases, the radius decreases, velocity of electron increases and energy of electron decreases. Okay. Now this is the inference that we have drawn. So they can ask you in a number of ways, as I have told you. Now a very good question. This, I think this is a new student from Sirsa, and see, this is the beauty of VSAT system. One person asks a good question and everybody gets benefited by that. The question this child is asking is, he says, sir, velocity is increasing, why energy is decreasing? What is the reason behind that? Now see, for that we have to go back to this formula once again, and you will see that I have used a negative sign over here, right, minus 13.6. Now the question arises, what do you mean by negative energy, right? If you get to know what is the meaning of negative energy, you will be able to understand why is the value decreasing. See, when we consider an atom and we put nucleus in between, so this is the nucleus, okay. Now there is one final boundary of the atom, there has to be. Say this is the outermost orbit, radius of orbit, okay. Zoom करेंगे please इसके ऊपर. Now suppose an electron is sitting over here. Zoom करिए. Right now you won't be able to see the difference in the two, but there is a difference over here which you will be able to see only once it is zoomed on. Yeah, और करिए, come. Yes. Now see, as you can very clearly see that this blue dot is outside this boundary, just outside this boundary, it is just outside this particular boundary, okay. So what we consider that this electron which is sitting out of the atom is actually sitting at an infinite distance from the nucleus. We assume it to be sitting at an infinite distance from the nucleus. Okay. So for this particular electron, we take n is equal to infinite, considering it to be the infinite orbit. Okay, beta. Now if you use this formula, E is equal to minus 13.6 z square by infinity square. So anything by infinity will become 0. So this value becomes equal to 0. So what do we mean? We mean to say that this electron is having 0 energy. Okay, it is having 0 energy. Now tell me one thing, beta. If the electron is falling to the lower energy shells, say suppose these are the lower energy shells, when it is falling down, tell me, is it losing energy or is it gaining energy? What is happening? When it is falling down, it is gaining energy or is it losing energy? What is happening? If you are standing on the 10th floor of a building, you will have higher potential energy, or when you are standing on the ground, you will have higher potential energy. So your answer should be that a person who is standing on the 10th floor will be having a higher potential energy. So when he comes down, he loses energy. So this electron is losing the energy? Tell me. So because this electron is losing energy, so 0 minus anything. If you say the initial energy was 0, so 0 minus any amount, A will be minus A. So the energy of the electron will be negative. So if the electron was, say, in the black orbit, or it is in the blue orbit, or if it is in the red orbit, what is happening? You will say, sir, we are moving closer to the nucleus. So when we are moving closer to the nucleus, the energy should decrease. Zoom out karenge. So what you can see over here, when you are moving towards beryllium, the radius is decreasing. You see, the radius is decreasing. Means you are coming closer to the nucleus. So when the radius is decreasing, the energy is increasing, also decreasing. The energy is also decreasing because this will have the least energy as compared to the blue, as compared to the black. That is why when the electron is falling towards the nucleus, the energy is decreasing. Now what? For hydrogen atom, yes, calculate them beta. Calculate the value for energy for hydrogen atom. The formula I will repeat once again. It is minus 13.6 Z square by n square electron volt per atom. Okay. Calculate the values of energy. Clear? So now, but obviously this value will be 0 as told to you earlier. This will be minus 13.6 electron volt per atom. This will be minus 3.4 electron volt per atom. This will be minus 1.51 electron volt per atom. This will be minus 0.84 electron volt per atom. Minus 0.54. Tell me, these are the values that you are getting, beta? है ना? These are the values everybody is getting. Yes, clear? Okay. So, what is the inference that we can draw from it? See first part. On moving away from the nucleus, the energy of electron increases at infinite distance from the nucleus the energy is 0. Okay. Second point. Now look over here, beta. What is the difference between E1 and E2? You will say, sir, the difference is 10.2. What is the difference between E2 and E3? Somewhere around 1.9. E3 and E4, 0.6. E4 and E5, 0.3. So if you see, the difference in the successive energy levels is decreasing. So this is also being asked in the exams. What is the statement? What is the statement? On moving away from the nucleus, the difference in successive energy levels decreases. Tell me beta, is this point clear to everybody? Any doubts? Sir, velocity contains kinetic energy, but if velocity increases, so why energy decreases? This is a question asked from Sirsa. Very good question, Sirsa Center. See beta, the total energy of an electron is equal to kinetic energy plus potential energy. Okay? Now Sirsa is asking another good question. He is saying, sir, if the velocity increases, the kinetic energy should increase, so the total energy should increase. Why is it decreasing? The reason is over here. The kinetic energy is given by the formula minus half kz E square by r, plus, and potential energy is given by minus kz E square by r. So if you see, the potential energy is 2 times the kinetic energy, and potential energy is having a negative sign. Okay, so the net value that comes out to be is minus half kz E square by r. So in a way you can say the total energy is minus times of kinetic energy. So which means if kinetic energy is going to increase, the total energy is going to decrease. Is it clear? Sirsa Center? Okay, there is a query from Bhatenda. Sir, will the energy become positive? The electron is farther than infinity if possible. Beta, try to understand, this negative value is only for giving you the direction. If an electron is not in an atom, then it just has got nothing. And 0 we are taking for a reference value. You can take the value to be positive. But see, you have to explain when the electron is falling from top to bottom, or from a higher energy level to lower energy level, it should release energy. So when it is releasing the energy should become negative when it falls from infinity. It is not going away from 0. So I cannot talk about a positive energy value. Just think of it. Where would you go? Where would you go? It is as if you are saying, okay, sir, I am standing on the 10th floor of a building. I have got some potential energy. So when I go to the ground, my potential energy becomes 0. So if somehow I go inside the earth, my potential energy will become negative. Arey bhai, it happens only in movies. ठीक है, वो रामायण में हुआ था, you know, that the earth opened up and Sita Mata went inside and then it closed. No, it doesn't happen nowadays, okay? That's not going to happen. So you just cannot go inside the earth. chalo, let's have a party at the center of the earth, let's go down. You can't do like that. Not possible, na? So similarly, when the electron is outside the atom, he will not say, oh my God, we are free, let's move. Arey, move where? It needs some energy source to move from one point to another point here. Are you getting my point? So he excited the electron and hydrogen and observed the various rays which were emitted when the electron fell down to the lower energy levels. Okay? Now, what is this? N1, N2. N2 is the orbit from which electron is falling. Orbit from which electron is falling. Orbit in which electron is falling. So the electron can fall from 2 to 1, 3 to 1 or infinity to 1 like that. Okay. If it is falling in the first orbit, we call it as Lyman series. 2, it is Balmer series. Paschen, bracket, fund. It is not P fund. P is silent here. It's fund. And Humphrey series. Okay. In Lyman series, we get ultraviolet rays. Here, visible rays. In these three, we get infrared. And here we get far infrared. Okay. Now, there are few things which are very important, which are like the language which they will be using for this type of question. Listen to this very carefully. When you say 2 to 1, it is the first line. Infinity to 1, it is considered as the last line. Okay. Now, instead of using the term first line and last line, they can also say from 3 to 2, alpha line, 4 to 2, beta line, and so on. Alpha means first line, that is 3 to 2, the first line is alpha, second line is beta, third is gamma, like that they can say. Okay. Now, the most interesting part is, see, the electron is falling from any orbit, 2, 3, 4, whatever. If it falls to the first orbit, all the radiations are in ultraviolet rays. How is it possible? To get the answer of this question, you have to do something. You have to do certain calculations. Now, what calculations you have to do? You will calculate for me energy of second orbit minus 1, energy of infinite orbit minus 1, energy of third orbit minus energy of second orbit, energy infinite minus second, energy 4 minus energy 3, energy infinity minus energy 3, energy 5 minus energy 4, infinity minus energy 4, energy 6 minus energy 5, You have to do this calculation, and where are the values? See, these are the values you have calculated. Use these values, okay, to tell me this. Yes, this is 10.2, this is 13.6. Yes, what is E3 minus E2? 1.9, 3.4. What is E4 minus E3? 0.6, 1.51. What is E5 minus E4? 0.3, 0.84. Right? Getting the point? Yes. What is E6 minus E5? What is E infinity minus 0.5? 0.38. Then this is 0.1 and this is 0.28. 0.54. Okay. Now beta, look at the board. My dear friends, this is Lyman series. This is Balmer series. This is Paschen series. This is Brackett series. This is Fund series. This is Humphrey series. So what have we got over here? The energy of the first line, last line. Now dear friends, see, this is the minimum value of energy emitted, this is the maximum value. This is the minimum value of energy emitted, this is the maximum value. Do you see any overlap over here? Tell me. The maximum value over here is minimum as compared to this one. Are you getting my point? So what does it mean? What is the meaning of this thing? It means that if you get a strip, now look at the board very carefully. If you get a strip like this, where you are observing the hydrogen spectrum, what you will get is, here first of all you will get UV rays. UV ray. This is between 13.6 to 10.42. Okay, but then there will be, say this is, suppose this is the UV ray. Then there will be a huge gap, because from 10.2 to 3.4 there is nothing, no line, no radiations. So here what is this? This is visible. Vibgyor, from violet to red. What is this? This is simple blackness, nothing will be there in between. And then after some distance, this is infrared. And as you can see over here, see, 0.54 is lying between 0.3 and 0.84. 0.38 is lying between 0.16 and 0.54, isn't it? 0.84 is lying between 0.6 and 1.51. So here the values are overlapping, and that is why you see Paschen, Brackett, Fund, all are lying in which series? Infrared series, right? Humphrey, again, see, far infrared is infrared rays but with lesser energy. So these are overlapping. So that's why they are infrared rays. They are not overlapping, they are simply different. Right? Are you getting the point? Now would you like to see the hydrogen spectrum? Mera mobile dena yaar zara. Now I will show you how the hydrogen spectrum actually looks like. You have to visualize this hydrogen spectrum now. Zoom kariye please. Okay. Now see, she is setting up this is the hydrogen gas tube. You can see some radiation coming out, but now we are putting a diffraction grating equipment with the help of which we will be able to visualize all the various radiations. Okay. So now she will darken the room. Right now you can't see anything else except this. Now we will move the grating or this particular side on one side. Like you see, darkness. You see there. You see the ultraviolet rays. Again darkness. See the infrared rays. See, ultraviolet, Vibgyor, and then the red one. You see, nothing. This spectrum is brighter in the dark. So if you simply go dark totally, yeah. Now see. Now let's move on the right hand side. You see now all dark, all black. Here comes ultraviolet, here comes Vibgyor, here comes infrared. So you see these are the separate lines which you will see in the hydrogen spectrum. Understood? Zoom out kariye. Understood beta? So when I said ultraviolet, then visible, then infrared, you saw how they were separate lines, and what was there in between? Nothing, dark, totally black. The same diagram is given in your NCERT books. Now when you see that diagram in your NCERT book, you will be able to understand what do they mean by it. And this is simple, a small diffraction grating equipment. If you can, use very high quality equipments over there, you can further divide this visible light into the 7 colors. You will be able to see those 7 colors also. Okay? During electronic transition. See, suppose the electron is falling from N2 orbit to N1 orbit by N1 square. Okay? So this thing will be written as 13.6 Z square 1 by N1 square minus 1 by N2 square electron volt, and this is E. Now there are two things which you need to know. First, E is equal to hc by lambda, and the second thing that you need to know is 1 electron volt is equal to 1.6 into 10 raised to power minus 19 joules. Right? So if I put both these things over here, I will be getting hc by lambda is equal to 13.6 into 1.6 into 10 raised to power minus 19 into z square 1 by n1 square minus 1 by n2 square. Okay? This thing I can write as 1 by lambda is equal to, now the value of h is 6.6 into 10 raised to power minus 34 joules second, and c is 3 into 10 raised to power 8 meter per second. Okay? So this will be written as 13.6 into 1.6 into 10 raised to power minus 19 upon 6.6 into 10 raised to power minus 34 into 3 into 10 raised to power 8 into z square 1 by n1 square minus 1 by n2 square. Okay, fine. If you solve this thing, you will be getting 1.1 into 10 raised to power 7 z square 1 by n1 square minus 1 by n2 square. And let us try to find out the units of this. See bache, what is this? The numerator is in joules, this is joule second, and this is meter per second. स्क्रीन ब्लर हो रही है, थोड़ा कैमरा ठीक करेंगे प्लीज. राजेंद्र, स्क्रीन ब्लर है, कैमरा हिल गया देखो. Yes, now it is fine. Joule will cancel with joule, second will cancel with second, so the unit will be meter inverse. Meter inverse. And this value is termed as Rydberg's constant. So your formula comes out to be 1 by lambda is equal to RH into Z square 1 by N1 square minus 1 by N2 square meter inverse. This is how you will be calculating the wavelength for all the radiations which are emitted when the electron falls from higher energy to lower energy level. Okay.